Hi, my name is Jonathan. Welcome to SD-WAN, high availability, and scalability. Basically, we're going to talk about clustering here. Basically how to scale for the number of controllers, branch devices, and data center devices. We're also going to discuss the deployment options for high availability in the control plane, as well as vManage cluster basics, such as how the cluster is going to work and some basics. Okay. So this is the last section of this section. So the next section after this, well, we'll talk about it later. So after this, we basically should describe the scaling numbers for controllers, branch devices, and data center devices, and describe the deployment options for high availability in the control plane. And we're going to also talk about the vManage cluster basics, such as how the cluster works and operates. So the SD-WAN solution is highly scalable, beginning at the controller level. You can cluster vManage to the levels required and add vBond orchestrators and vSmart controllers. You should connect each vEdge to a minimum of 2 vSmart controllers. vSmart controllers reach their limits, simply add more and balance the vEdge routers between them. All right. Here's some scaling numbers for the control plane, starting from the vEdge. Each vEdge is going to have one non-permanent connection to vBond, one permanent connection to vManage, and one permanent connection per transport network to vSmart. This is only the control plane. The vEdge routers, of course, also have data plane tunnels. All right. So if you have 3 tunnels, right? Let's say MPLS and 2 internet. All right. You've got 6 connections to vSmart. Okay. Remember, because we have 2 vSmarts, so you're going to be connecting to 2 of them on each connection. Okay. So each vBond scales up to 1,500 connections each. If you need more than one vBond, DNS load balancing is required. So you're going to have to do that DNS load balancing externally through a DNS load balancer. On the vEdge routers, you can configure a full qualified domain name for vBond, the same as on the vSmart controllers, and let DNS balance between the vBond servers. So the vSmart connections scale to 5,400 connections, and each vManage cluster instance is up to 2,000 devices. Okay, so 5,400, 5,400, 5,400, and then we got 2,000 for each. Okay. Each vSmart has its own IP address, and the balancing is done automatically by the solution, right? So you're going to make connections, and it's going to load balance stuff automatically. Remember, these connections to vBond are going to be transient, all right? So when we first boot up, we're going to connect to it, and every time we reboot, we're going to connect to vBond to find our vSmarts and vManage. Okay. In larger networks, you might want to restrict the vSmart controllers that a vEdge should connect to. Having a vEdge in America connecting to something in Asia Pacific is a little, inefficient. This slide's showing a global network with 1 global vManage and 3 regional data centers containing your vBonds and vSmart controllers for the region. Load balancing between the vBond orchestrators is performed on DNS. So a vEdge in America region will be directed to by DNS to the IP address of the regional vBond, right? So we're going to actually set it this way because when it looks for it, it's going to look for the local one as well. And selection of vSmart controllers is going to be done by configuring affinity. Okay? So the way we do this is the vSmart controllers are placed into regional groups, and these 3 groups are configured on every vEdge. So in principle, every vEdge should be configured to know about all vSmart groups. Then with the system controller group list command, you configure an affinity by selecting the group numbers in the preferred order. The fact is that edges from one region will normally connect to only the vSmart controllers in their own region, but will fail over to vSmart controllers in less preferred regions if necessary. So this vEdge here will connect to local vSmarts, but if these vSmarts blow up because the data center got taken out, we'd actually go over to here. But we would set this as our secondary, this guy would be set as our secondary preference and then a tertiary preference. All right. So we'll always have backup. Remember, without vSmart, we can't really do a lot of our route reflection, and a lot of our network kind of goes bad. So in the horizontal side, we can have a number of data plane tunnels supported on the vEdge is going to vary. If you've got the vEdge 100, we only support up to 250 tunnels, and 1,000, 1,500, and the 2,000 and 5,000 have 6,000 tunnels. We also have equal cost multipathing between the two, and that's what ECMP stands for if you didn't know. Generally, there's an acronym explosion that occurs here, and a lot of this may be new to you. So that's equal cost Basically what it implies is that if I have multiple connections, I'm going to load balance across them. Okay? So vManage is going to scale as a cluster. From any other device such as vEdge, vManage is going to appear as one single IP address. And load balancing between the devices within the cluster is not visible to other devices. Within a cluster, all vManage instances are in an active mode. For this to work, all members of a cluster must be in the same metro area to keep the delay between single servers low. If failover between regions is required, only an active standby model is supported. The vManage database is synchronized between sites, but only the active vManager cluster is visible to the network during normal operation. A complete loss of vManage does not impact the data plane operation. All right? And then traffic will flow as before. But remember, the vEdges have the configuration on them of how to connect to each other. All right? As long as vEdge and vSmart is up and running, you can take vManage out of the equation and the network will operate as it should. Now, we do lose quite a bit. We can't make any administrative changes. We don't collect statistics. You don't have the ability to detail into flows. You can't troubleshoot at all. We can't make any, because each device is being managed by vManage, all right, we can't go into the CLI and do anything other than show commands, okay? So, yeah. Remember, each vEdge is also going to report all of its statistics to vManage, so if vManage doesn't exist, those statistics are probably going to be lost. All right. So the vManage cluster is going to consist of at least 3 vManage devices, which provides the scalability. Each vManager supports approximately 2,000 devices. So a cluster of 3 vManagers can support up to 6,000. They automatically load devices between the devices they manage. It also provides HA. For HA, at least 5 vManage devices are required. So there is an odd number of vManage devices. That means if a vManage fails, the remaining devices in the cluster continue to operate with a majority quorum. Just so you're aware, when I mention the quorum, I'm not making some political joke. These guys do vote, and if we don't have an odd number, we could have a tie, so we need to have an odd number of devices at least, okay? And we'll talk about the way they vote, and why they vote. It's basically about the fact that if I've got changes happening on all of them, the majority that have that changes will win, okay? So, basically, in a cluster setting, the administrators are going to connect to the GUI on the application server of any of the vManage devices. A permanent automatic synchronization occurs between all devices through the message bus. So if a user logs into this one and a user logs into this one and they both make changes, right, those changes happen automatically between the two, right, and are synchronized. This is like a lot of other publisher-subscriber environments, but they're basically we are equal here. So changes here automatically get propagated. Okay. The more devices there are, the more traffic each device handles, the busier the vManage is going to become. While we say that the vManage can handle up to 2,000 vEdge devices, we have seen the vManage become overburdened long before reaching 2,000 nodes in some situations. It's especially true if you enable both DPI and CFloud. Those are the NetFlow, basically the statistics collection and the flow data. And data is being collected by the vManage. This inundation of collected statistics, alerts, events, configuration, maintenance is tasking on the disk, memory, CPU, and the interfaces. The vManage device in the cluster share all the statistical and configuration database information between them. So not only are they collecting all this data from all those vEdge devices, they're also sharing it dynamically. This can cause it to, bog. Okay? So because so much information is shared between the devices, a separate interface is used for inter-cluster communication. Don't attempt to use the same interface for the cluster and for the control connections to the other devices. Also, the latency between the devices must be very low, and the interface must be in VPN 0. Okay? Let's see. So the statistics database and configuration database services are going to run on an odd number of vManage devices with a minimum of 3. All right? For these databases to be writable, there must be a quorum of vManage devices running and in sync. A quorum is just a simple majority. For example, if you have a cluster of 3 vManage devices running these databases, 2 must be running and in sync. If you have 9 in the cluster, 5 must be running and in sync. Initially, all vManage devices run the same services. However, you may choose to not run some services on some devices. From the cluster management window, you can select which services to run on which devices. For example, you might want to add a fourth vManage to load balance more vEdge devices, in which case you would disable the statistics database and configuration database on one of those vManage devices because those services must run on an odd number of devices. Okay? So if I have let's say I have 9 vManage servers and I disable services on one of them, now I have an even number of services, so I need to now disable those services on yet another one to make sure I maintain the oddness of the service count. Okay. Also, you may want to run the configuration database on only a single vManage to reduce the amount of information shared between devices in order to reduce the load. Changes to those cluster configuration do require that those NMS services are reloaded. Often a reboot is going to be required, though. Any vManage cluster configuration changes should be made during a maintenance window. So, just so you're aware of what the cluster requirements are, we do have a 5 millisecond round trip time on the system, and that's right here. All right. So you're not putting one of these in New York and another one in Los Angeles. They're going to be in the same subnet. And they do require a third interface, as we mentioned before, because of the amount of traffic. Okay. So how do we do this? How do we deploy all these servers in a cluster? Well, basically, it's pretty straightforward. We're going to back up the database with the following command: request NMS configuration backup. Okay. We're going to add the third NIC. We're not going to use DHCP. This third NIC is going to use for the cluster messaging between the devices within VPN 0 and for nothing else. For vManage to detect the new interface, the device must be rebooted and configure a device and verify. So to create a cluster, go to Administration, Cluster Management, add another vManage until you need at least 3. Remember, we need at least 3, and any odd number will work. Add the vManage IP address of a third interface, used for clustering, username and password, and on the right, select the services that vManage is running. Okay? And of course, we need to make sure that that device reboots. Okay? And then the cluster will show that it's rebalancing, and then the services are restarting. Okay? Just so you know, vManage 1 is also going to restart its services as well, which will eventually reset the GUI session, and you're going to have to log back out. You're going to have to log back into the system. Okay? All right? And so what we do is we go under User Settings, and then we'll add a vManage. And basically, you would install that vManage just like we did before in sections of eons past. And then just enter here the IP address of that third interface. Okay? So again, basically, we set up these vManages exactly the same as any other vManage we're installing. We just actually specify the IP address, and that's the way this connects to the cluster. Okay? So we can't add the new vManage server to the cluster until it is added into the GUI. All right? And this IP address should already exist on the local device. If it isn't, it's going to reach out to it right now. Once you hit update, it's going to reach out to this IP address and try to connect to it. If it isn't there, it's going to fail. Okay? After it's successfully installed, add a third vManage exactly the same way. And the new vManage will be showed in configuration certificates up here. It's down. There's a sub-menu under certificates up here, and then it'll be in there. If you're using enterprise certificates, generate a certificate signing request, have it sign and install the signed certificate for the new vManage. vSmart. vSmart's redundancy. It doesn't require any particular configuration except affinity to regions if multiple regions are required. Each vSmart's going to have the same view of the fabric, and synchronization between them is also automatic. A vEdge connects to a maximum of 3 vSmart controllers. It's recommended that the vEdge connect to at least 2 vSmart controllers. A single vSmart connection is sufficient for full configuration, but remember, if we lose all that, we lose a lot of features. Remember, if no vSmart is available, the fabric keeps working in its current state, so there's no impact on the data plane traffic. However, no policy changes can be made at this point. Remember, all the policy changes are routed through vSmart, so we configure it on vManage. They get pushed to vSmart, and then vSmart pushes them to each of the systems. Okay, so if the vSmart's down, any policy changes are over. Okay. Every time a vEdge boots, remember, it connects to the vBond. It bonds to vBond. This is why an IP address or hostname of vBond must be configured on each vEdge or provided through a plug-and-play or zero-touch provisioning. vBond provides the vEdge with all further information that it must have to operate, such as which other controllers to connect to. If more than one vBond is required, the vEdge routers must configure with a fully qualified domain name, not an IP address, and DNS load balancing must be configured to distribute the overall load to all available vBond controllers, servers. Okay? Remember, this DNS load sharing is going to be external to the environment. You're not going to configure that inside here. It's going to be configured in DNS. We point to a full qualified domain name, and then DNS is going to route us to a vBond. That'll usually happen in a round-robin fashion, but depending on your DNS load balancer, you can set up priorities for each individual one. Okay? So just so you're aware, if all the vBonds are down, no new vEdges can join the overlay. Okay? And if you reboot a vEdge, it's probably not coming back. So vBond is just as important for redundancy as the other devices. Okay? Just remember, I want to keep hammering this in. The data plane is going to be completely independent of the control plane. Even if all the controllers are unavailable, it's going to keep operating. vManage is going to be viewed from the network as a single IP address, and scaling is done through clustering. So you're going to have one virtual IP address you're going to connect to, and it's going to take you to the vManage that's active. Okay? All vSmart controllers are independent, each with an identical view of the fabric. Each vEdge is going to be connecting. We're going to need to connect to at least 2 controllers. Well, at least 1, but ideally, when you do a show control connections, we should see at least 2 sessions there. And you can scale those vBond controllers as independent controllers also, but you're going to have to configure load balancing to share the other load over vBond orchestrators. Okay? That's the end of this little topic, but we're going to do a little summary of the end of this entire section. Basically, this entire section was about deploying the SD-WAN controllers in public or private clouds. Each device requires a basic configuration before you can manage them. That basic configuration is configured via templates or, if you want, CLI. We have an option for zero-touch provisioning so that we can actually send a device out, have them plug in, and it'll automatically connect to the network. And remember, templates are available for scalable and reliable management of edge routers and vSmart controllers. The templates are really powerful. They're really awesome for simplifying a lot of configuration. And they scale pretty much infinitely. And basically, you can scale up every controller to as large as you need it to be. Thank you for watching. That concludes this section.